Hello everyone, welcome to Pratibha Tech. In this video, we will solve the problem of the day question on Geeks for Geeks for 19th February 2023. The problem statement for today is fixing two swapped nodes of a BST. This problem is based on binary search tree and this question has been asked in Paytm, Amazon and Microsoft interview questions. So let's now open this problem. First we will go through the problem statement. Here it says two of the nodes of the binary search tree are swapped. Fix or correct the BST by swapping them back. Do not change the structure of the tree. It is guaranteed in note it is given that it is guaranteed that the given input will form BST except for two nodes that will be wrong. Let's go through this example. Here it says that this is the given tree where the elements are 10, 5, 8, 2 and 20. And here it says the output is 1. So here it says that if we swap these two nodes 20 and 8, then this binary search tree will be fixed. That means it will be in proper structure of a binary search tree. So that's why, see, if after swapping, if you are able to form that correct BST in correct sequence, then the output will be 1. So similarly, if we look at the second example, so it is saying that with this tree, if we swap 10 and 11, the BST can be fixed. So before approaching to any solution, so now let's first understand that how this BST used for solving this problem and what is the concept we used here. So here we can see this is the same tree. This is the same tree but with the swapped version which I have drawn here is 10, 5, 2, 8 and 20. If you can see, then 20 and 8 both are swapped. And even in the explanation it is said that if you swap this one, then this forms the correct BST. So whatever is there in my editor, so this is the correct BST. So how to verify this one, this is the correct BST? So the logic here is that in case of BST, if we do in order traversal of that BST, then the numbers or the nodes value will be in ascending order. So this is that concept which we will be using to solve this problem. So here we can see it will be in the form of root. See, this 10 is the root of this tree. Then left node is here, it is indicating 5. Then right is 20. So here in order traversal, what we do, first we traverse the left node, then root, then right node. That is in the form of L, N and R. Left node, right. So this will not happen just for the top subtree, it will happen for each and every node. So if we consider this entire tree, then this is that node, that means root node, and this is the left node, this is the right node. But for this again, this subtree which is from 5, this is the 5, 2 and 8. So again this 5 acts as the root node, 2 acts as the left and 8 acts as a right node. So and for this one, if you look at this 20, then 20 doesn't has any left node or right node, or the left child or the right child. So here it is, both the left child and right child will be blank or null. So here if we do the in order traversal, then so how we will do that? First we will go to 10, then we'll see that, first we need to print left, then root, then right. So first we'll go to left node, and here before printing this 5, we will first check that if B is having any child node or not, or not. Yes. So here we will see that 2 is the left node and 8 is the right node of 5. That means right child of 5. So first what we will do, so before printing this 5, we will again apply that in order traversal of left, root and right node here as well. So after that we will get, first we will print the left node. Here we will get here 2. Then we will print the root node. Here it is 5. Then we will print 8. So this subtree is done. Now since it is done, now the next option we have to print the root. So it will be here 10. And then we will go to this right subtree. Here we will check, does it has any left or right child? It doesn't have. So here if you try to print anything in the left child, it will be null. Then root, it will be 20. Then right child, it will be also null. So here it will only come, it will 20. So if you see this, this is in the sorted order. That means 2, 5, 8, 10, 20. So this concept we will be using for solving this problem. What we will do, we will first traverse this entire tree and we will create a subtree. That means we will store all the node value and we'll sort it. So see, since we are seeing that the resultant of this tree, that means inorder traversal of a tree, will give it in a sorted order. So if we sort all the element and then if we compare with the each value of the tree in order traversal again, then we can clearly replace the values whatever is there in this tree with the values whatever we have got after sorting those elements. So that way we can easily solve this problem. So here we will be using just two concepts here. Three concepts. First we will be traversing the BST using the in-order traversal and store the node values in a list. Then we will sort that list of node values. Then as a third step, what we can do, traverse the BST again using the in-order traversal and update the value of each node with the corresponding value in the sorted list. See, instead of comparing here that whether this value is greater than this one or less than this one or any kind of comparison, we can simply sort all the values. We'll get in the proper ascending order, and that order is the ideal sequence of the BST. So we'll just compare and just see where it's not matching with the order of the sorted list. That value will just replace it with the corresponding value from the list and our solution will be done. So using this approach only, let's start coding the solution for this answer, that means for this problem. So here what we can do, first one, we'll create a list of integer. We'll give this name as values is new array list of this one. Then what we'll do, we will do the in-order traversal of the tree using this root. We'll pass this and we'll pass these values also, so that we can store each node value inside this values list. So once we are done with this in-order traversal, then what we can do, we can simply sort all the values which we have got there. Sort values. So now after this we will get in the desired sequence whatever we have shown here. This is 2, 5, 8, 10 and 20. Then what is the next step we have? We have the next step to update the tree. Update tree, we'll pass this root, then we'll pass these values, and here we will pass the index. That means that will indicate which index value is being updated. So before that we'll create this index variable, index, and this is a single element value that we will be creating and we'll be storing 0 in that, and that will be passing. So here we can see that this index of the array, the integer array of with the name index, whatever we have created. So this we are creating with the name index with a single element and initializing it with a 0. The purpose of this array is to store a single integer value which is the current index in the sorted node values list that is being used to update the BST. by using an array instead of a single integer value, we can pass this variable as a code through this code, and this can be used to update values across recursive calls. That means we can pass this updated value. The code can pass the value, can pass the array as a reference to the update tree function, and allowing it to modify the value of the index variable across recursive calls. This is necessary because update tree function needs to keep a track of the current index in the sorted node value list as it updates the BST. And this index needs to be updated across all recursive calls. So for that reason we have created this one. So now we are done with all the steps whatever we will be doing. So now we will be simply creating the function to traverse it with inorder. So here we'll create a function called public void inorder, and we'll be passing here node with root and list of values. So this we are calling this function only. We are passing root and we are accepting the list of values here. List of values. So once we get this in order function, then we will first check if at any point root is null, then we can return from that point only, return, else if root is not null, then what we will do, we will do inorder traversal of root dot left. We'll pass these values again, then when we come to our root node, that means every moment, then we will keep adding the value in this values array, add saying root dot data, then again we will traverse the right one. So this is the general way we use the recursive calls which we use to do a inorder traversal of a binary search tree. So right, so first what we are doing, first we are traversing the left part of a node, then we are printing that node, or we are doing whatever we want to do with that particular root value, then we are traversing the right part of that node. So at each moment when we are at 5, so we will first look at the left subtree, that means left node, that root dot left, then whatever we will get here, then here we need to see that when we are starting, then when we are at 0, when we are at 2, so here also see it doesn't has any left child or right child. So in order of root it will give null, in order of right it will give null. So that's why first we are printing this one. So I hope this is very clear. So this function is done. Now what we will do, we will update the tree with the updated value whatever we are getting after sorting the list. So we'll just writing that function of update tree. Here is the node root, then we'll pass the list of values again, and here we'll pass the integer array index value. That means that array which whatever we have created to store the value of from the updated sorted list. So now here also we will do the same inorder traversal. So we'll copy this and I'll just try to change some values. Okay, so and here it will be root is still again equal to null, but only the thing is that here we will be doing some different operation. Here instead of calling in order recursively, now we will be calling update tree, then here also update tree, and here will be passing the left root of the node, then here will be passing the right child of the node, that means any node, and here will be again passing those three variables, because we are calling this method only recursively, so whatever is required in this method we will pass. So here it will be again this one index. Now we need to update this one. So what we need to do, here we will update each time the root data with the values whatever we have got in the sorted array list. That means the sorted list whatever we have done, and we have done it the collection.sort. So we will replace that with the corresponding value from that sorted list. Here it will be index of 0, and each time, that means for each next iteration we will just take the next value from this list, so it will be plus plus. I hope this is very clear. So here we can see what we have done. First we created a simple array list. We have done the in-order traversal of that particular tree, and what we have done while doing in-order traversal, I've just stored the values, each values in this values array. And once we got all these values in an array, we will just sort it. The purpose of sorting is that we can directly compare the values in the in-order traversal of the tree with this sorted list, and we'll just replace the values in the tree from this corresponding sorted list. And so for that only we are calling this update tree. So that's it. So I think I'm done with my coding, and here at last we need to return the node. So return the node, that means starting node. Here it will be root node, so that we can traverse in while fetching the output. So yeah, so now let's try compiling this code. So here we can see we have got our output as 1. That means after doing the swapping of the node values, we have been able to form the correct BST. So now let's try submitting the solution. So here we can see we have got all the test cases covered. So we have solved this problem successfully. Yeah, so that's all in this video. Please like, comment and share the video, and please subscribe to the channel for more upcoming videos. Thank you for watching.